In video number 14, we are going to be talking about angles, arcs, radii, and how they relate to each other within the same circle, and also how they can relate to each other between different circles that are dilations of each other. So let's first just consider these two circles right here. And notice that there's a bunch of different dimensions labeled with letters. And in the littler circle, they're all lowercase letters. And in the bigger circle, they're all uppercase letters. Also, the bigger circle is a dilation of the first or the smaller one with a scale factor of k. So you take everything here, you multiply it by k, and you get everything here, almost. Now, with that being said, so the C stands for the circumference. So the little c is the circumference of the little circle, and the big C is the circumference of the big circle. The little d is the diameter of the little circle, so all the way across. And then the big D is the diameter of the big circle. The little r is the radius of the little circle, so halfway across from the center out to the edge. And then the big R is the radius of the bigger circle. And then this little a is the area of this sector, and then the big A is the area of the sector. So let's just first consider the fact that if the scale factor is k, that means if you take these dimensions over here and divide them by over here, the ratio that you would get is k. So like the big C over little c, or like the circumference of the big circle over the little circle, or this radius over that radius, or the big diameter over the little diameter, all is going to have a scale factor of k. And that means we learned back in like February or so that if the scale factor is k, the area factor is going to be k squared. So those are some relationships that will always hold true between circles that are different sizes, because we also learned that when thinking of circles, every circle is a dilation of another circle. So we can also think about relationships within one circle. So for example, we know that the circumference, the formula for the circumference is 2 pi r. So in the little circumference equals 2 pi times the little radius. In the big circle, we get the circumference is 2 pi times the big radius. We also know that the diameter is just twice the radius. The radius is halfway across, the diameter is all the way across. So the little d would equal twice times the little r. And that also holds true in the big circle. The big diameter equals twice times the big radius. Now we can use this to come up with a ratio of what the diameter divided by the radius will always be. So that means, so let's say we want to find the ratio between the diameter and the radius. So we divide by r. So now we have the ratio of the diameter over the radius, and it just equals 2. And over here in this other circle with a different radius and a different diameter, it still equals 2. So no matter what size circle you have, the ratio between the diameter and the radius will always be 2. And that makes sense because the diameter is always twice the radius because it's all the way across versus halfway across. Now we can also think about the fact, well, if the diameter is just twice the radius, we can take this same equation from up here and write it a little bit differently. If 2 times r is really just d, we could say that the circumference is just pi times d instead of pi times twice r. So I'm going to rewrite the circumference equation like this. So circumference equals pi times the diameter, and circumference of the big circle is pi times the diameter of the big circle. Now, if I want to know the ratio between the circumference and the diameter of every circle, I can just find the ratio of the circumference over the diameter, and I can do that in any size circle, little or big or whatever size, and it's always going to end up being pi. That's actually how they figured out the value of pi. Is when I say they, I mean like, people a long time ago that figured these things out. They took a bunch of circles, they measured around the circumference, they measured across the diameter, and they noticed that every time they divided those two numbers, they got this number that was slightly bigger than 3. 3.1415, blah, 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 to be exact. So they said, well, that's interesting. Now we have this number that we always get whenever we take the circumference and divide it by the diameter. So we need a name for this number, so they called it pi. And that's where pi actually came from. It's always the ratio of the circumference divided by the diameter. So those are some relationships of different parts of a circle within each circle and how they compare to each other, like with a scale factor. Now, we're also going to look at some ways that we can use these equations to find missing parts. This is essentially very much like what we did in the last video, but I just thought it would be nice to have a few more examples. So let's look at this example here. If we have a circle, we know that the radius is 4 inches. We know that the length of the arc that we want to look at is 6 pi. We need to find what that central angle is to make it that length of an arc. So what we're going to do, because we're looking at the length of an arc, we're going to be using this first equation right here. Let me move this up a little here. So the length of the arc is 6 pi, so I'll start with 6 pi equals, and then the central angle, which we don't know, divided by 360 times 2 pi times the radius, which is 4. So now I'm just going to solve for the central angle. I'm going to divide both sides by 8 pi. That gets rid of all this over here because 2 times 4 is just 8, so all that cancels out. The pi's cancel out, and I just have 0.75 equals that fraction. Now, if I want to find what the central angle is, right now it's being divided by 360, so I'm going to multiply by 360. That cancels out, so that means that the central angle, 360 times 0.75, is really 270 degrees. So if you have some of the information, you can use this equation, or this one, but in this case we use this one, to find missing information. Here the missing information was the central angle, so we plugged in what we knew, and we solved to find out what we didn't know. Over here, we have the radius, we have the central angle. We're looking for the length of the arc that we would have given these two pieces of information, and the area of the sector that we would have with these two measurements here. So let's do the length of the arc first, since that is just written first here. So the length of the arc is the central angle divided by 360, so I'll say 45 divided by 360 times 2 pi, and my radius is 3. So now I just have to solve this, simplify it until I figure out what the length of the arc actually is. So the length of the arc is 45 divided by 360. If I do that in my calculator just to make it a decimal and not a fraction, because fractions can be kind of tricky to work with, 45 divided by 360 gives me 0.125 times, and then 2 times 3 is 6 pi. So I can simplify that even more. 0.125 times 6 is 0.75. Then I still have my pi. And I just did that in my calculator, 0.125 times 6. I just used my phone and figured out what that was. And then, so I could leave it like this. I could say that the arc length is 0.75 pi. Or I could simplify that and do 0.75 times, 3.1415, all that. And I get that the length of the arc is 2.36 inches. Okay. Now I can use that same information and plug it into this equation, and then I'll have the area of the sector that matches this. So if the length of the arc is 2.36, I can use that same information and plug it into this equation to get the area of the sector. So the area of the sector is going to be 45 over 360 times pi r, which is 3, should have just wrote 3 right there, squared. Okay, that's a 3 squared, in case you're wondering. So that means that the area of the sector, I already figured out that that's going to be 0.125 because it's the same in the other equation, times 3 squared is 9 pi. So I can simplify some more. 0.125 times 9 is 1.125 pi. And then I can figure out what that actually equals. 1.125 times pi is 3.53 inches squared because it's area, so it's going to be square inches. Okay? So you can take the information that you have, and then you can use it to find different missing parts. Go ahead and try the practice, see how you do, and good luck. If you have any questions, feel free to email me, or you can show up at one of the meetings, and I can help you there too. Good luck.